Hello, math students. Welcome back to Statistics and Probability, and this is Lesson 5, and it is called Calculating Probabilities of Compound Events. Our goal for today we will practice calculating the probability of compound events using tree diagrams. The question that I want you to think about is, how do you determine the probability of a compound event after diagramming it? Because we haven't really spent a lot of time looking at that. So hopefully by the end of the lesson it will be very comfortable for you. All right, so some things to know. We're not really learning anything new per se, but we're learning how to continue or follow up with the information that we've been working with. So basically the best way to do this is to jump in and try it and see what we come up with. So under the Let's Try It section, it says, in a laboratory experiment, 3 mice will be placed in a simple maze that has just one decision point where a mouse can turn either left or right. Okay, so that's what you need to be thinking about in that little experiment, and let's see what happens next. It says, when the first mouse arrives at the decision point, the direction he chooses is recorded. The same is done for the second and the third mouse. Okay, so hopefully you're visualizing in your mind there's 3 mice that were dropped into a little maze, and they have to make a decision when they get to the first decision point, and that decision all the way through the trial is only to decide, are they going to turn left or are they going to turn right? Okay, and we do that with all 3 mice. So what we're trying to figure, a tree diagram, when they say the decisions for that we have, okay, that's the decisions to work from diagrams. Sometimes people work from the top down on their tree diagrams. It's all truly just a preference of what you want. So in this blank space in our notes, I'm going to work from left to right so that I have enough room. So the first thing that it said to do was focus on the first mouse. Okay, so the first trial that we're looking at is first mouse, and the first mouse only has 2 choices. They have the choice to turn left, and they have the choice to turn right. Okay, so if you only have 2 choices, I want you to think about that. What is the possible probability for the first mouse? Well, if you're thinking about what they have 2 choices, they have to choose one out of the 2, then we would know that the probability is 1/2. Okay, so it's the probability to turn left would be 1/2, and the probability to turn right would be 1/2, because there's only 2 choices. Okay, so then that's trial 1. All right, so now we have to find the probability of mouse 2, which we would like to call that the second trial, so we're going to call it second mouse. All right, so second mouse. Okay, and we're building off of first mouse, right? So second mouse has the option to turn left and turn right. But then if you also think of it this way, if first mouse went left, and so we're connecting those as branches, second mouse could go left or right. But if first mouse went right, then second mouse has the option of going left or right also. Okay, so I don't want you to get confused by this, because remember, we're talking about multiple trials within the same situation. Yes, this is all second mouse, but second mouse's probability is based on what first mouse did. Okay, so second mouse still has 1/2 to choose left and 1/2 to choose right, because there's only 2 directions. If they choose left, that would be 1/2. If they choose right, that would be 1/2. Again, if first mouse chose right, then second mouse would have the choice of going 1/2 left or 1/2 right. So we're just trying to keep everything that we have as possible outcomes linked together, and then we'll build our trees once we're done. Okay, so that's second mouse. Now let's go on and look at third mouse. Okay, so here's third mouse here. And we have third mouse's options are, again, first mouse went left, let's say second mouse went left, so third mouse also has the option to go left, so that would be 1 out of 2. First mouse went left, second mouse went left, third mouse could go right, right? Okay, so now first mouse went left, Second mouse went right. Well, third mouse also has the option to go left or right, right? And then we have to address these two down here also. So what if first mouse went right, second mouse went left, then third mouse has the option of going left or right. And then if first mouse chose right and second mouse chose right, then third mouse has the option to go left or right also. So again, this is 1/2, this is 1/2, this is 1/2, and this is 1/2. And darn it, the problem with tree diagrams are now rearing their ugly heads, and that is that they take up a lot of space. Okay, so I'm trying to do this to kind of prove a point that sometimes having tree diagrams is huge. Understanding them, using them is amazing. But as you can see, if you don't have a ton of space, they get really tight. So now we're going to look for outcomes. And the way we look for outcomes is by the branches. So I have a branch from first mouse choosing left, connecting to second mouse choosing left, or second mouse choosing right. So there's our first tree. Okay. Then I have first mouse who chose right, then second mouse could go left, or second mouse could go right. So do you see the branches starting to come together? You should. So now we have first mouse choose left, second mouse choose left, third mouse can choose left, or third mouse can choose right, right? First mouse can choose left, second mouse can choose right, and then third mouse can choose left or right. Okay? What if first mouse chooses right, second mouse chooses left, third mouse can choose left or right? What if first mouse chose right, second mouse chose right, third mouse can choose left or right? So this is showing all of the possible outcomes. So again, to remind you, our last column that we keep track of is all of the outcomes. And I just like to write out what we see. So I have a left, and a left. There we go. Okay? And now I see a left, but a right this time. Okay? Now I see a left, a right, and a left. And I see a left, a right, and a right. Okay? So all of my lefts are now done. Okay? Now I have to move to my rights. So it would be a right, a left, and a left, a right, a left, and a right, a right, a right, and a left, and a right, and a right, and a right. Okay? Now, remember, go back to the directions. It says 8 possible outcomes. So let's count them and make sure we have all 8. 1, 2, 3, 4, 5, 6, 7, 8. So we found all the possible outcomes, which is awesome. Okay? So now what we have to do is we have all of these outcomes right here, but we need to figure out what their probability would be. That's why in the very beginning we talked about what their probability was of their choice. So this L right here represents a half. So let me change color again because I want to make sure that you guys are following me with this. So I want to choose one that I haven't used yet. So let's go with, well, we'll do gray just because it's different. All right, so this L was a half, right? This L was a half, and this L was a half. So when we multiply all of those together, right, we get 1 times 1 times 1 equals 1. 2 times 2 is 4. 4 times 2 is 8. Okay? Now, hopefully, you guys are all recognizing that we know that each one of these choices of how to turn for the mouse, they all have the value of a half because you could only go left or right, which is 2 choices, but you chose 1. So that means the probability is 1 out of 2, or a half. So I am leading us to believe that this is a half, 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 this is a half. So remember, what you do with the choices that they make is you multiply them together. So every single one of these choices that we have listed out is going to be 1/8. Okay, so that's 1, 2, 3, 4, 5, 6, 7, and 8. So all of these have a probability of 1/8, okay? And so the other cool thing to know that you did it right is because these are all the possible outcomes. They told us originally that there were 8, so if you count them up, we have 1, 2, 3, 4, 5, 6, 7, 8 eighths, which gives you 1, and 1 would be 100%, so you know you got it right, okay? So that's how we determine the math for these. So you take the outcome that you had, its probability, and you multiply it by all the other probabilities that exist. So the probability of having all left turns is 1/8. The probability of having 2 left turns and 1 right is 1/8. The probability of 2 left turns and a right is 1/8. The probability of 1 left turn and 2 rights is 1/8. 1 right and 2 lefts is 1/8. 2 rights and a left is 1/8. 2 rights and a left is 1/8. And all 3 rights is 1/8. Okay, so hopefully you're seeing the pattern of that. Now, the reason why we need to know how to find these is because of this question down here. So it says, if the probability of turning left is 1/2, and the probability of turning right is 1/2, what is the probability that only one of the 3 mice will turn left? One of the 3 mice will turn left. So what you have to go back up into our outcomes is you have to find where that is listed. So let's look for that. It says, what is the probability that only one of the 3 mice will turn left? So let's look. Okay, left, left, left. That's all 3 mice. Left, left, right. That's 2 mice. Left, right, left. That's 2 mice. Ah, 1 mouse turned left. So here's one of them. Okay. 2 left for mice. Oh, 1 mouse went left, so there's another one. Oh, 1 mouse went left, so there's another one. Right, 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 so that one doesn't count. So now it's saying, what is the probability that only one of the 3 mice will turn left? And so now that we know, it says that we have to take the probability of what that would be, right? So the probability of having one of the 3 mice turn left would be what? So you know the probability of this one is 1/8, you know the probability of this one is 1/8, and you know the probability of this one is 1/8. So how do we figure that out? What would we do? Okay, that's what I'm looking for you, because we're trying to find the probability of compound events. Okay, you're trying to find the probability of compound events. So you have to take the information that you know, and you have to figure out what would be the result. Well, this is 1/8, this is 1/8, and this is 1/8. There's 3 different outcomes, so that might give you some ideas to think about. So I have this one, LRR plus RLR plus RRL, because all of these combinations show 1 mouse turning left, and then I know that the probability for this one is 1/8, I know that the probability for this one is 1/8, and I know that the probability for this one is 1/8. So what is the probability that only one of the 3 mice will turn left? Maybe think about it. What do you come up with? All right, so that's what we're looking for when you get to class tomorrow, okay? Because I really feel like it's important for you to understand that last step of what you are supposed to do. I kind of told you without telling you if you paid attention to the video and looked, okay? So kind of good. Remember, compound events means you're taking one event and you're putting it together with another event, and in math, putting something together, ta-da, is represented by this symbol. So hopefully, without me giving you the answer, you're being able to determine it yourself. Okay? So our goal for today. Today we will practice calculating the probability of compound events using tree diagrams, which is what we did. How do you determine the probability of compound events after diagramming it? You have to combine them. You have to put them together. In math, what does putting together mean? Okay, that's all I'm going to say. We'll talk about it some more in class. Talk to you soon. Bye!